This lesson is an intro to trigonometry. Before we even start, you need to make sure that your calculator is in degree mode. If you're using a TI-83 or a TI-84, it's the button that's right next to the second button. It's blue on my calculator, but it says mode. You click that, scroll down 2 or 3, and there's a choice between radian and degree. You want to make sure you select degree. If you're using one of the scientific calculators from our class, the yellow ones or ones that look like those, again, it's just to the right-hand side of the green second button. It says mode, hit that, and the very first choice is between degrees, radian, and gradients. You want degrees. Any other calculator you can Google, but again, there should be a button somewhere that says mode. You need to make sure that it's in scientific mode, degree mode. There are a couple problems we'll get to that all you have to do is put it in your calculator, but you're going to miss it if you don't have it in the right mode. So the overall objective, students will be able to use trigonometry to find the missing sides. But before we get that, there's a couple things that may not be on the test. There's some like this that are similar on the test, and it's not that much it's not that much different, and it's not any harder than what we've done already. I just want to make sure you guys see it before we see it on the test. So find the missing side lengths. We have the square root of 17, 5, and x. So we're going to use the Pythagorean theorem. Now, the thing that's different with this one is the square root of 17. We haven't had one that's a square root. So the big thing you guys have to realize is, remember when we were doing Pythagorean theorem before, and at the very end of the problem, you have x squared is equal to 36, and then to cancel out the x squared, you take the square root. The square root cancels out the squared. Well, it works the other way around too. If we have a square root of something, like the square root of 17, and we square that, those cancel, that's just 17. So this is actually even a little bit easier when they do that, because you don't have to use a calculator, because you already know the square root of 17 squared is just 17. So when we do the Pythagorean theorem with this, we have a squared plus b squared is equal to c squared. 17, the square root of 17 squared, remember we just said those cancel, so this one's just 17. 5 squared is 25, c squared. Add those together, we have 17 plus 25 is 42. I guess I put c squared, I could have put x, doesn't make any difference. And the last step, you take the square root of all those, the square root 42 ends up giving you 6.48. Go on to the next one. Now, both of these are square roots. But again, don't make it harder than it is. Just make sure you remember this is the hypotenuse. So this one is the square root of 7 squared plus x squared is equal to the square root of 14 squared. But again, this one's actually easier than a lot of them because these squares and square roots cancel. So it's 7 plus x squared is equal to 14. Subtract 7. X squared is equal to positive 7. Then take the square root of both sides. You end up with x is equal to, and again, I would type the square root of 7 in your calculator, 2.66. Make sure you're rounding. On the last quiz, a lot of people missed some points because they didn't round it all. Make sure you are, 2.65. Got carried away. 2.65, make sure you're rounding. And the last one, prove that this is a right triangle. So this is on coordinate geometry, and there is a question like this on your test, I assure you. Now, there's several different ways to do this. The hardest way is to use the distance formula and to find the distance of all these lengths and to make sure it works with the Pythagorean theorem. So find the distance of this length. We'll call it A. Find the distance of this length. We'll call it B. And then find the distance of this length, we'll call it C, and then just make sure that a squared plus b squared is equal to c squared. Make sure that's true. Plug those numbers in and see. Remember to use the distance formula. It is x2 minus x1 squared minus y2 plus y2 minus y1 squared. Take the square of that whole thing. So the problem is that takes a lot of time because you have to do that formula that I just said 3 times and then plug it in here. Now, I would love to take the time to do that, but I'm not going to right now because I'm a little bit crunched for time. If we were to do this in class, I'd take the time to show you. But instead of doing that, if we want to prove that this is a right triangle, rather than just using the Pythagorean theorem, all we have to do is prove it's obviously a triangle. We just have to prove that this is a right angle. Well, the way we do that is use the slopes. Remember, if they're a right angle, that means they're perpendicular. Remember, perpendicular means they meet at a right angle. And perpendicular slopes are opposite reciprocal. So remember, the opposite is, if our slope is positive, the opposite is negative, and the reciprocal is y over x instead of x over y. So again, now there's two ways to do this. You could use the slope formula, y2 minus y1 over x2 minus x1. You do it for this slope and for this slope. But since they give you this picture, why even take the time to do that? Why wouldn't you just count? So what's the slope? Do the rise over run. I always start with my left-hand point. So we go down 1, 2, 3, 4, so negative 4. Then we go over 1, 2, 3, so it's negative 4 over 3. That's the slope. Let me rewrite it over there so I can see negative 4 over 3. Now let's look at this slope. Again, I start with my left-hand point. You don't have to, but I think it makes it easier. This one goes up 1, 2, 3, so it's positive 3. Then goes to the right 1, 2, 3, 4. Are these two opposite reciprocals? Yeah, opposite. One's negative, one's positive. Reciprocal, 4 over 3 and 3 over 4. So yes, opposite reciprocal. So that means that these two lines are perpendicular, so that means it is a right triangle. And that's going to be way easier than any of those other options, especially using the distance formula. And again, you will have one like that on the test. I probably should go over more examples, but again, it comes down to being able to find the slope and knowing that it's opposite reciprocal, and that shouldn't be too bad. That's all stuff that you guys did in Algebra 1. In Algebra 2, that's where you came from. So trigonometric ratios. You don't have to write all this down, but the big thing that you'll learn is the trigonometry that we're going to do is sine, cosine, tangent. And it's the sine, cosine, and tangent of the angle. So the angle we represent by this Greek letter called theta. Now the ratio is sine of your angle is the opposite side over your hypotenuse. Cosine is your adjacent side over your hypotenuse. And tangent is your opposite side over your adjacent side. Now, if that doesn't make any sense, that's okay. We're going to talk about that. So if we have a right triangle here, so this is a right triangle, we never are talking about this angle. So don't worry about that. So we're going to talk about one of these other two angles. Let's focus on this angle right here. So if we're focusing on this angle, when I'm saying opposite, hypotenuse, adjacent, the hypotenuse is always the same. The hypotenuse is always the longest leg. But the opposite side for this angle is always the angle always the side that that angle doesn't touch. So this is the opposite side. Then over here would be the adjacent. Adjacent means it's right across from each other, right next to it. If you say it's the adjacent house, it's the house right next to yours. So if we're trying to find the sine of this angle right here, the sine of this angle is the opposite over hypotenuse, so it's the opposite side over the hypotenuse. That's the ratio. Now, here's the problem. This is what you have to make sure you realize. The adjacent and the opposite, the hypotenuse will always be the longest side. We already know that. But the adjacent and the opposite, that will switch depending on what angle you're talking about. So if all of a sudden now I'm talking about this angle over here in red, now this is my opposite because that angle doesn't touch that side, and this is my adjacent. So you always have to make sure you're being aware of that. So if you're still a little bit confused, don't worry. We'll get there. Oh, I almost forgot. This SOHCAHTOA is one of the things you'll hear, or when you talk about trig, we'll talk about a lot. And it's just a way to remember that sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent, SOHCAHTOA. That's one of the things that you hear a lot with trigonometry. So let's do some of these examples. So sine of an angle, and when they put an E on it, that's just how you're actually supposed to spell it. We just put SIN for the abbreviation. Sine of an angle is equal to the leg opposite the angle and the hypotenuse. So again, it's the opposite over the hypotenuse. So they're saying sine of angle A. So angle A is this angle. So if they're talking about the sine of this angle, the opposite is 3. The hypotenuse is 5. So the sine of A is just 3 over 5. If you can reduce that fraction, make sure you do so. But that's all there is to it. The sine is the opposite of our hypotenuse. A lot of people, when they hear trigonometry, they think it's like really super difficult. And trust me, it can be. But this basic stuff shouldn't be that hard. You just have to make sure you know SOHCAHTOA, and you have to know what it means and know where to find the opposite and adjacent in a hypotenuse. So that's usually easier. Now, that's the sine of angle A, but if we would have done the sine of angle C, now all of a sudden we're talking about this one. So now this is the opposite, but again, the hypotenuse is still the same. So the ratio for the sine of C is different because now it's 4 over 5. Cosine. So SOHCAHTOA is AH, so it's adjacent over hypotenuse. So again, we're talking about the cosine of angle A. So this is the adjacent, this is the hypotenuse. So this one, the ratio is 4 over 5. And now angle C, now this one's the adjacent, this one's the hypotenuse. So we have 3 over 5. Again, reduce if you can. And the last one, tangent, is the only one that doesn't have the hypotenuse in it. It's the opposite over the adjacent. SOHCAHTOA. The tangent of A is the opposite over the adjacent, so it's 3 over 4. And then, sorry, I must have not typed this, or must have forgotten to do this. This says tangent of C. And that tangent of C is the opposite over the adjacent, so it's 4 over 3. So that's really what we're looking at. We're going to try to figure out some different things, and we'll do some different math with this. But this is the most basic part of trig, and this is the part, again, this is the part you guys have to know and be really good at. There's no reason you shouldn't be. Oh, I put it on there. I just didn't delete it over there. Okay. So find the sine, cosine, and tangent of angle P. I encourage you guys to pause the video now and do these on your own, and then hit play and just make sure you did it correctly. So the sine is opposite over hypotenuse. So the opposite, we're talking about angle P here, so the opposite and the hypotenuse. And it doesn't hurt to label those. Eventually you might not have to, but I would definitely encourage you to do it here at the beginning. Reduce that down if you can, but if you can't reduce it down, that's fine. Cosine of P. So now we're talking about the adjacent. So SOHCAHTOA, adjacent over hypotenuse, is 8 over 17. Again, reduce it if you can. And tangent is TOA. So SOHCAHTOA, opposite over adjacent. So my opposite is 15. We already labeled that. Over adjacent is 8. Again, reduce if you can. Now, one real quick thing, if you notice this or if you want to remember this, the hypotenuse is always in the denominator, and the opposite is always in the numerator. If that helps you. Again, personally, I think it's just easier to memorize SOHCAHTOA, but if you want to remember that the hypotenuse is always in the denominator, I think that helps a little bit. And then, again, one step further, the opposite is always in the numerator. Same thing, I would encourage you guys to pause this and do this on your own. Now we're talking about angle S. So this is going to be the opposite. This is the adjacent. This is the hypotenuse. So the sine, so SOH, the opposite over hypotenuse. So CA for cosine, adjacent over hypotenuse, A over H. And TOA, opposite over adjacent, 8 over 15. So again, I know we're drilling this into the ground, but now you can try some of these out. The sine of A, again, opposite over adjacent. And if you want to label these, you can, but just remember, if you label them for A, that's going to be different than B. If you're labeling for A, this is the opposite, this is the adjacent. But if you label it for B, it's going to be the opposite way, so be careful with that. Again, I would encourage you to pause this, do it on your own quick. So is opposite over adjacent, or sorry, opposite over hypotenuse, so that's 8 over 10. That reduces down if you divide by 2, 4 over 5. Cosine of A is the adjacent over hypotenuse, so 6 over 10, which is 3 over 5. Again, make sure you reduce your radicals, or sorry, reduce your fractions. And tangent opposite over adjacent of A, so the opposite is 8 over the adjacent is 6. That's 4 over 3. 4 over 3. Now let's do, so the sine of B, so it's the opposite over the hypotenuse. That's 4 over 5. Cosine of B is the adjacent over the hypotenuse, so 4 over 5. Hold on, I did something wrong. I had this one right, I reduced wrong. If you divide both by 2, 6 divided by 2 is 3, not 4, so that's my fault. And the tangent of B is the opposite over the adjacent, 6 over 8, which is 3 over 4. Not too bad. Now, if you thought that last part was easy, I hope you did, but this is even easier. Do this one, all you do is put it in your calculator. There's no way, I don't even know how to do this without a calculator. So the sine of 58, just type in your calculator, you get 0.848048. Remember, it says 4 decimal places, make sure you're rounding. So you're rounding to this one, that 4 doesn't make that go up, so just 0.8480. If you didn't put the 0, I can live with that. Tangent of 86, again, just type in your calculator, 14.3007 when you round, because it's 300666. Sine of 52, 0.7880. Cosine of 55, 0.5736. Again, these I think are on separate slides on the next one, so I don't have to worry about those. Yeah, they're right here. Cosine of 7, 0.9925, and tangent of 21, 0.3839. Now, I will say, if you're doing the X-Tick or if you're doing homework and you don't have your calculator, look one up online, use your phone. Most of your phones, if you switch it to where it's like landscape going side to side, most of them are scientific and most of them have those. But again, you could also just Google it or go to Desmos. All your computers have a TA4 on there. Now, before I go on, if you didn't get the same answers for any of those, it's probably because you're in radian mode. If you're in radian mode, it's not going to come out with the same answers, and that's a huge difference. I've had people that I make them redo the test because I can tell, but I've had people that fail a test all because they didn't do any of it in degree mode, so make sure you're careful with that. So now we're going to use trigonometry to find missing sides of triangles. So now instead of using Pythagorean theorem, we couldn't use the Pythagorean theorem because we don't know this side and we don't know this side. With the Pythagorean theorem, we know 2 out of the 3. But we don't know that side, but we do know this angle. So this is how you're going to start this one. We're talking about angle 34. So that's the angle we're focused on. So the 2 other angles we're working with is the opposite and the adjacent. Well, if you're looking at SOHCAHTOA, which one has the opposite and the adjacent? TOA, so we're going to use tangent. So we start with tangent, and then that is always followed by the angle. So far we've been putting theta. This is the first time we've had an angle. So we have the tangent of 34 is equal to the opposite over the adjacent. So 11 over x. Now we're going to solve for x. Now remember before what we were doing with when we found the tangent of 21, we typed it in our calculator. So technically right away, and don't do this, but technically we could do the tangent of 34 is 0.674585. You could put that in there and you could do it that way if you wanted to. But I'm going to wait till the very end to make sure it's more accurate, and that's what I want you guys to do as well. So how do we solve for x? Well, this one's a little bit tricky. I should have put an easier one before this. But we actually have to kind of take a sideways step. When your x is in the denominator, we need to get it out of there, so we actually need to multiply both sides by x. Now I'm going to show you a shortcut after I show you this. So if you multiply both sides by x, that cancels. So over here we just have 11. Over here we have x times the tangent of 34. Now we need to get rid of the tangent of 34. And again, this is the hard part for some people to grasp. The tangent of 34 is just a number, just like it was 10 or 13 or 6 or whatever. So if I had 6 times x, how would I get rid of that 6? You divide. Well, that's the same thing. We just divide by tangent of 34. So x is equal to, just put this in your calculator exactly how you see it. 11 divided by tangent of 34. It's going to put that parenthesis in. You can leave it like that. So 11 divided by the tangent of 34. X is 16.31. It doesn't tell me where to round, and so I'm going to go to 2 decimal places. So that's really all there is to it. Now, I will tell you the shortcut that I know at the very beginning here. If you ever have your x in the denominator, like this, the thing, a lot of people try to multiply by 11, and you can't do that because 11 is the numerator. If you have your x in the denominator, just take that x and take this tangent of 34 and switch their places. That's literally what I just did. That's what I showed you guys. X is equal to 11 over tangent of 34. That's just kind of a shortcut. And that works with anything. If you ever have a fraction and your denominator is the variable, you can always switch it with the other side. So that's a little shortcut for that one. But again, once you know SOHCAHTOA and you know which function to use, this really isn't too bad. So now we have 64. That's the angle we're talking about. So what are the other 2 pieces of information we know? We know this one is the adjacent because it's right next to it, and it's the hypotenuse. So if you look at SOHCAHTOA, adjacent hypotenuse is with the cosine. So cosine of my angle is equal to AH is the adjacent over the hypotenuse, x over 20. Yeah, I should have done this one first. So now my x is in the numerator. It makes it way easier. To solve for your x, you just multiply both sides by 20. And then, again, just type that out. 20 times the cosine of 64. Again, when it types in your calculator, it's going to put a parenthesis there. You don't have to put another one if you want to. You can. But that one, x is equal to 8.77. Again, I'm going to go to 2 decimal places because it doesn't say so. It might say something on your notes. I'm not sure. This one, this is the angle we're talking about. So we have the opposite in the hypotenuse. So that's opposite hypotenuse, and that's the sine. So the sine of that angle is equal to the opposite over the hypotenuse. Again, we see that shortcut. That x is in the denominator, so that x and this can switch places. So it's x is equal to 17 over the sine of 40. Again, the long way to do that is to multiply both sides by x, and then divide by the sine of 40. And in your calculator, 17 divided by sine of 40 is 26.45. This is the angle we're talking about. And again, it's important to make sure you know what angle you're talking about because this is the opposite and this is the adjacent. But if you're talking about this angle, it'd be different. They'd be switched. So this is the angle. Opposite and adjacent is the tangent. The opposite is x over the adjacent is 14. Multiply both sides by 14. And again, the hard part of this is knowing which one to use and then knowing which one goes in the numerator and denominator. So make sure you know TOA, opposite over the adjacent. 14 times the tangent of 54 is 19.27. Now again, I would pause these, do these on your own, then hit play to get your answers. We have the hypotenuse and the adjacent, so that's cosine. So toa. Ka is a over h, so x over 14. Multiply both sides by 14. We have the opposite and the hypotenuse, so that's sine, so OH, so sine 31 is equal to OH, so x over, our hypotenuse is 19. Multiply both sides by 19. X is equal to 9.5. Didn't give you any with x in the denominator. Should have done that. That's okay. So if you have any questions, make sure you let me know. And again, this is just the very basics of trig, so we won't go very deep. There's one more. We're going to do another part later. That's a little bit more difficult. You're going to be finding the angles. But other than that, that's all really the trig we're doing. And again, trig can get really, really complicated, but we are not going to go that far in depth, so it shouldn't be too bad. If you have any questions, let me know. Other than that, good luck.